Thanks for coming and welcome to this week's edition of our Office Developer Hours. My name is Russ Festino. I'm a developer advocate for Algorand. Also, we have the DevRel team here. It's going to help out with some Q&A today. We got Ryan Fox and Jason Weathersby. All right, so let's start getting into it here. Are you new to ASA development? Number one, how do you get started and what the heck are tokens anyway? As well as, when I do figure that out, how do I create my own? And what can I use them for? Can I do it from an SDK? And how do I do that? And once I've created it, how can I get some status on the assets? How can I query to get asset information? And what about if I'm not a developer? How do I visually create assets without code? So these are all questions we'll take a look at here today. In the three sections we're going to do our ASA blockchain use cases to give you kind of a feel for what assets can be used for. And we're going to dive into ASA specifically, and we'll end with querying ASA and using some tools. So some of the use cases, these are all documented up on our use case site at Algorand. And we'll start out with the props network. So this turns app users into loyal financial stakeholders. And what it does is it provides a platform to extract a blockchain's technological complexity for apps. In other words, they have widgets you can incorporate in your apps as well as use APIs to programmatically access loyalty programs, which is a really cool idea. And it's SEC approved tokens as well as ecosystem is what it provides for token holders. And there is a video that we have up on our site as well on moving from Ethereum and over to Algorand with the props network and what they did there to do that. So again, that's a use case. You can see the link right there. We'll provide a link to this deck at the end of the session as well. Then let's take a look at one more here, Circle and Coinbase, a Central Consortium, actually the two entities, Circle and Coinbase, joined forces to form this Central Consortium. And what it's all about is payments and treasury infrastructure for the internet. So it's built to accept payments and send payouts globally. And how does it do that? Well, it can leverage traditional payments through credit cards and bank accounts, or it can also do it through blockchain infrastructure. So that really makes it accessible globally and very scalable as well as efficient. And it provides USDC, which is the fastest growing stablecoin, over 2.3 billion in circulation. So this is really a great player, and we're seeing a lot of activity on the blockchain with this particular effort. And more of these types of use cases are available at algorand.com/use-cases. And Asset Block, for example, is another one there that does tokenizing of real estate assets. So you can have real estate divvied up among multiple stakeholders through percentage of assets. And a lot of other ones that are actually using Plant Watch, another one using assets. So specifically, what is ASA and how can I use it? And how do I get started? Well, the how do I get started part, the easiest place is the Sandbox 2.0. Now, we covered this in the prior dev session, and I just wanted to cover one thing. We had some additional questions on follow-up, so I'm going to talk about that next. But for those that missed it, basically, you simply install Docker, and then you clone the Sandbox, and you're pretty much good to go. The version of Sandbox is new. It's a 2.0 version, and it defaults to a private network. And that's the biggest difference for anybody that's been using Sandbox to date. It used to default to testnet. So now for testnet, you specifically need to put that as a parameter. So it would be .sandbox up. If you leave anything out, everything else out, you get private network. Or you can specify testnet, betanet, mainnet. Those are all supported. And that is the link to the office hours that we have. Ryan did the session on last week. Specifically, this area here, I think, needed some clarification in terms of usage, just on our networks in general. So being that the Sandbox now is a private network, it does lack public explorers, but you can query and find out transaction amounts or asset information using the Goal command line tool or the SDKs. That might be a good project for Dev Rewards, for example, maybe to do a little browser for the private network. Funded accounts are provided in the Sandbox, which is a very good thing, right? So now you already got accounts ready to go, already created, already funded. If you do create new accounts, either through using Goal, which we do through a KMD wallet, or through AlgoKey, which facilitates doing standalone accounts, or the SDK code, Then what you'll have to do is dispense algos from provided funds accounts using goal or STK code. Indexer is built right in, and that's the beautiful thing about the private network here with Sandbox. You can actually do some testing with Indexer, and we're going to use Indexer later on today to show you how to do queries. The three networks in the Sandbox that are available are the BetaNet, TestNet, and MainNet. There, you account balances are network specific. So in other words, if I have an account A on BetaNet and the same account address on TestNet, those are going to have reflect the balances in those environments and mainnet as well. So you might have 200 in mainnet, 100 in testnet, and maybe 5 in betanet. So that's the thing I want to clarify. So this has caused a few issues in terms of, I thought I had funds in there, but they're not there. Well, maybe, you got to look at the specific network. And then you can also query accounts with public blockchain explorers, SDKs, or Goal. You can use the testnet, betanet dispensers to fund accounts, as well as indexer services are available through either building your own or through a couple API service providers in the way of PureStake or Algo Explorer. So that is in a nutshell in terms of what you have and don't have and the benefits of each in the environments in Sandbox. So very easy. You bring it up and then you're ready to go, and it gives you information on the address and tokens that you would need in all the different environments. All right, so let's talk about ASA. And so what this is all about is creating native tokens. And native tokens are created with the ability to have administrator functions as well as asset spam protection, and resides on layer 1. Very, very important. This is really facilitated right on the basics of the blockchain, Algorand blockchain, on layer 1 itself. So what are tokens used for? Well, you can, use those for create gaming assets, for example, or you can use them for creating coins or your own currency. These are all very good uses for it. We'll go through in depth a little bit more some of the other cases. For example, right now there are two categories here: fungible tokens and non-fungible. So let's talk about fungible first. Typical examples here would be used for in-game points, stable coins, loyalty points, and stable coins. We'll talk a little bit more about. That's what we were really talking about up front with a couple of the use cases that we had shared. Or you can use the system credits. Basically, these fungible type tokens are all have the same value each. So if you create 500 stable coins, each stable coin is exactly the same and worth the same amount at the same time. You have securities and government issued fiats fall under the restricted fungible tokens. By restricted meaning there could be some clawbacks can be used to have funds go on the reverse address if you wanted to. And then we get to the non-fungible type of tokens, and these could be in-game items that are very unique. It could be used for supply chain sign-offs. It could be used for real estate transactions, right? Or real estate solutions. The way, in my mind, a good example to differentiate between fungible and non-fungible. The non-fungible for real estate, for example, you may have a house with 4 bedrooms and a 2-car garage on one street. And then you have the same type of house, or it could be the same exact house, same number of rooms and garage in another geo. And there's a lot of differentiators between the two. Is it downtown? Is it city? Is it in the park? Is it rural? How close is it to highways? All that kind of stuff. So those are different values, right, for each one of those type of assets. So that's, in my mind, the easiest way to remember that. Good for identity, certifications, collectibles, and then also restricted, used for real estate and ownership registries. So a good sampling here of different types of assets that can be used and some of the ways that they are used. When we are using ASA, there's basically a life cycle. First thing we got to do is create the asset. And then there are management functions you can provide. Who's going to be able to freeze accounts, or who's going to be able to manage accounts? Who's going to be able to do clawbacks? There are functions that are set for each one of those, and you can divvy it up against multiple accounts. Now, in order to receive an asset, you as a user must opt into that asset. So in other words, these assets cannot be just blindly distributed to the masses, and that really helps prevent people from getting unwanted assets. You have to want to get in. Once you've opted in, then you can accept these tokens or send them even, all right? So you can do transfers. You have the ability to also freeze an asset. Maybe in a game, you fail a level, you're going to freeze the asset until they, go to the next level or something like that. Revoke, or sometimes referred to as clawback, is another step that can be done. And then finally, if you do have all of the assets in the creator account, you can destroy them. I just finished up doing these tutorials, about a week ago, I think. And so these are all brand new on the dev portal. If you just go in to type in ASA, you'll see working with each language. We got examples in Java, Go, Python, and JavaScript, tutorials that go through every step that I just showed you. And I'm actually going to demo next. So let's go ahead and take a look at the demo. I'm going to run this first demo here in Python. All right, so here we're going to go hit our first breakpoint here, which is where we're setting the host address. I'm using the sandbox. I'm using testnet in this case. We've already restored some accounts that I have created before. Again, not a good practice in real code, but great for when you're doing demos and learning, because those are really your private keys. You want to protect those at all costs in a production environment. Now, let's go ahead and we'll get down to the very first asset transaction. So as you can see, I've got 3 accounts here. I've got account 1 down in the output window that begins with YQ. Account 2 begins with 6Fox, and JFox for address 3. And what we're going to do is we're going to set everybody up to account 2 in terms of the roles: the manager role, the reserve role, the freeze role, and the clawback role. And we're going to call this the rdevcoin unit name. The maximum characters for unit name is 8. You have much more flexibility on the asset name itself. You can make that robust. There's also a parameter here to specify the number of decimals that you want in the total amount that is also specified here. We do have a call up above to go ahead and get suggested params for the transaction, so those get passed in as a parameter as well. And that's really about it. You can also have a URL field that you could put information into, maybe to get more details about this particular asset. And the important thing I want to point in each one of these is who signs the transaction. So in this case, account 1 is going to be doing the creation. This is referred to as the sender in the account. And so the signer then is going to sign off. And once that's done, we're going to go ahead and broadcast that transaction to the network. And we're going to have a transaction ID. And once it's confirmed, then we're going to pull out this information down below. So I'm just going to let this run right down to that section. And the wait for confirmation is a utility function that we have to wait for it to actually get written to the blockchain. And then you can see right now we've got this asset ID that we're going to print out down below, and you can see it right there. Now the next step is going to be change manager, but I do want to point something out here. If you are familiar with any kind of a API testing tool, what we can do is just do a send here on that particular account. And then you'll see the information come back up very similar to what we just saw. So you can see there's a new one that just got created. This is that 471. Take a look at our lip. There it is, 4470. And then this is the withholding information, or the holding information. But this is the creator account information. So this is what specifies your clawback, your creator, your freeze, and manager, right? So that's just using a REST API call to get that. Going back to the code now, what we're going to do is take that asset that we just created and we're going to manage it. So before we had everybody here set to the second account, we're going to say, okay, the signer of this is going to be the current manager, which is account 2 that we established up in the first step. Remember, the manager here was account 2. Then what we're going to do is, so guess what? He's going to be doing the signing right on this transaction after it gets when we go to publish it. So all we're going to do is change the manager now to be account 1, which is going to be the guy that we had specified up there earlier as account 1. So I'm going to go ahead and fire this up and write that out to the network, and then we'll print the created asset information in the window down below here as well. And there it is. So now we've got that information. You can see got changed for the function of manager. It now belongs to YQ, which is the same as the creator account, and the other managing type accounts are still all at the 6Fox address. Next, we're going to go ahead and start to opt in, right? So On the opt-in section of code, this is really just going to do a transfer amount of 0 in this particular language. All the SDKs are very similar in functionality. Some of them have a unique call to do an opt-in versus a transfer. But this is the deal. We're just going to do a transfer of zero, and that's going to go ahead and have us opt in. Who signs it? Well, the person that is going to be getting it is account 3. That's the one that we need. That person needs to sign off and say, yeah, I'm going to accept this particular transaction. All right. So for those that aren't familiar with signing, it's basically you got two addresses, right? You got a public address everybody sees so you can receive funds. But if you're doing anything like wanting to send transactions, that's all done with the private key, and that's what you need to sign off with here when you're doing transactions, is the sending key. All right, so it looks like down below you can see the amount is now 0, and this is our account is enabled. Account 3 is enabled to go ahead and get assets transferred to them. So we're going to take some of those assets there in account 1, and we are going to transfer an amount of 10 to the account 3. And so 1 is going to go send it out, and that's going to then be in that account. And after we see the results here, now we should see 990 left in the master account, and the account 3 now has an amount of 10. And you can see that printed out down below. This is the freeze account function. So the freeze account function is saying, okay, we're going to freeze the second account. The freeze address, which is the second account, is going to freeze account 3's rest devcoin holdings, right? So that's what we're going to do here in this step. So now, because it's frozen, I can't send or receive. However, that does not prevent clawback and revoking the asset, which we're going to do in the next step. So the revoke asset step, then these all have the same kind of flavor to them. You have the call, you have the sender, you have the receiver, and other things that are information like the asset ID that we created up in the first step. And so this one here, we're simply going to claw back. The clawback address is responsible for managing that function is account 2. And we're going to revoke 10 of those from account 3 and place it back with account 1. So the back with account 1 is called the receiver account. And then the revocation account is down below, so that's 3. So now we're going to have everything back. All 1,000 of those are going to be back in the original creator account, which is account 1. All right, so we're going to go ahead and send that through. And the final step in this life cycle example is to destroy the assets. So now that we have all of the assets, and we can see that very clearly just by running our query here, and you can see now that we have all 1,000 back in this account. Once that's done, you can destroy the asset, and you must be in possession of all the tokens in order to destroy it. And this is going to be signed off again by our account 1, which is the creator account. And that's it. And so now we've gone through the full cycle here as well. And that is the demo on using this in Python, and very similar in the other languages like they talk about. This is an asset example for JavaScript. And then you can see over here, for those that are using JavaScript, again, I restore the accounts. And this is the important part where I'm going to come down and specify each of these parameters. And the method call that we're going to use here is going to be called make asset create tx with the suggested params, and pass those in. But it's the same idea, and you can just go right down this, and each tutorial that I pointed out has all of this sample code in it. All right, next thing we'll go ahead and show you here, ability to query ASA and some other tools. So for those that aren't familiar with Indexer, it's basically an off-chain type solution that feeds off the AlgoD process and updates a Postgres SQL database. This is accessible through all the SDKs and REST APIs through Go, Java, JavaScript, and Python. And it's really now instead of kind of search raw through the entire blockchain to find something, you go into a database, which just makes so much more sense. It's all indexed, it's all ready to go, and you can use it. Now, how do you get one of these indexers? Well, you can build your own. I built my own. That's one I'm going to be using here in the demo. As I mentioned before, you can use a service like PureSync or from Rand Labs, where there's API services in each. And then now we have a third option available with Sandbox as a default for private network. So that includes an indexer instance as part of that. So just bring it up by default, you're good to go and do some testing with Indexer. What does Indexer do? It provides search on transactions, accounts, and assets. And there's many filters you can apply. So I'm going to be showing you some examples, but keep in mind that they could be much more robust. You can specify a round number. If you want to speed up your searches, for example, and you know your asset didn't exist before a certain round, you can specify, from this round forward, do a search, right? And it'll come back quicker. So things like that will work to your advantage. And there you can see things like address you can do and search sender receiver addresses or balances, asset holdings. Also, you can look up historical account data for a particular round. You can do a search by a timestamp, do searches by asset IDs. Also, if it's a big query and you get lots of hits back, the result will be in pagination. So whatever the return limits are for the different queries, say it's 1,000, you get 1,000 in the first set, and then there's a pointer to the next set, and then you simply go ahead and go out to the next set and retrieve that next set in. So you can create a loop in your code basically to do the result information. Now, specific to assets and queries, you can use like search for accounts for an asset ID. Which accounts have my asset? Right. This one here, accounts for asset ID with a min-max balance. Maybe you want to create a leaderboard, right, for a game you're creating, and you want to say, oh, give me everybody that's like in the top end, and you specify a max balance, and it'll come back and give you that. You could do a query on asset balances, period. You can do queries on transactions with assets, with an asset ID, including roles. Is it a sender account, a receiving account, and the account numbers? You can do searches by asset, by name. I could do a search on Rust DevCoin, and it'll come up. Also, you can do search asset scored by asset ID. Now, the asset ID is the unique indicator. You do have a maximum of 1,000 assets per account. Now, that combines creator and holding accounts. And to get at a particular asset, you could do a search by name, but it's not guaranteed to be unique. You can get multiple hits on a name. The asset ID is unique. So that is the one that will always get you the one that you want if you're doing the search by the particular ID number. And then finally, you can do a search addresses by asset. So let's go ahead and take a look at this in the code. So here we see we've got an account. We did a query on the account balance for this asset ID, and anybody that's got it. So you can see that we got balances here for this is the account number 3 that I sent it to. This is the creator account that has 990 in it, and you can see all of those listed as such. And then let's go ahead and search next for a transaction. And there we go. So it found it right there. So this is the transaction that we use to do the transfer of the funds. And so pull that up. So that's a really useful thing if you're ever looking to pinpoint, when does this happen? This is a search on the Rust DevCoin one. And once this completes, you'll see it does a hit. It gets a hit on the Rust DevCoin that I just created right there. So there's all the information there. So a lot of great query tools, capabilities, searching by the asset ID itself, searching by an address and the asset that has a minimum, say. And what about creating assets visually, right? So there's a tool out there, algodesk.io. One of our partners wrote that, as well as there's a few more that are in the works, I understand, that are along this line. But basically, we'll demo that live. All right, so let's go ahead and build an asset. And so this is pretty straightforward. We'll go ahead and get started. So this is the account it's going to go ahead and create for you. You want to copy that off in case you have to restore it. And that's your private key. And then let's go ahead and create an asset. So do an asset name, unit name, total supply of that, how many are going to be decimals, or in addition to that, how many decimal points you want. So it'll be 20,000.0, my URL, and then use all the default addresses. So this is the account that is creating it. So now you can go ahead and create that asset. It'll come back over here and bring this up. So I go down right to the bottom here. We see that new Rust one that I created. You can see there is the manager address and reserve address and all that done. Then you have the ability to do a lot of those functions that we showed you in the code: send assets, modify, freeze, unfreeze, revoke, and delete. Or you can look at this in the browser. So this, hit that little browser button. It brings up Algo Explorer here, and you can see the actual address. And this is the information provided for the unit main. There is the asset ID. That's pretty much it. You get down, there's the transaction that occurred. You can actually see the transaction ID. Click on that. You can see who it was from, who it was to, the date of the transaction, and all the transaction details, right, that were used when creating it. So that makes it a little bit easier. A lot of great tools like that starting to come out. A lot of those are actually listed up on our developer portal. If we go out to the developer portal, you can see we've got documentation here. There is a community project section. And in here is a wealth of explorers, wallets, and API services, SDKs. A lot of great tools are specified in here as well. So let's continue on. And where's the code? I'll show you that. So really, if you just drill down into the docs, a lot of the feature documentation has links to the actual examples. So like this master tree right here is by feature, right? So you can get like start building, right? You want to do a basic transaction, always go to the V2. Then you see right there is your first transaction sample code. So that's a great resource. So we covered a lot of ground here today with ASA blockchain use cases. We went through an in-depth example of the entire life cycle of ASA, everything from creating an account to having to opt in, as well as managing it and providing transfers and other functions like you can do, like freezing an account and closing an account and revoking as well. We've got the PowerPoint and Discord. We encourage you all to join Discord to get some conversations going. If you're looking for, got questions about, what you're working on, great link there for tutorials and documentation, of course, developer.algorand.org. Forums, another great place to post your questions to. And office hour sign up. We had a couple more coming up, and the sign up is at algorand.com/developers. And I think that is it.